Uh, Welcome again, friends. Uh, Today we are going to discuss about the biasing of a PN junction device. In my immediate earlier video, I discussed about the concept of PN junction devices, the mechanism of their fabrication, and the concept of depletion layer and barrier potential, and the events that take place after the formation of a PN junction. Today we are going to learn about the biasing of a PN junction. You may have heard of the term biasing and have wondered what is biasing. Now, biasing simply means application of DC voltage across a PN junction. Applying DC voltage to any electronic device or circuit simply means to bias that circuit. So, the application of DC voltage, or to apply DC voltage to a device, in this case PN junction, is called as biasing. So that is the definition of biasing. Now we are going to discuss about the various methods of biasing, or the modes of biasing. In order to bias a PN junction device, there are two methods: forward biasing and reverse biasing. Okay, let us discuss them in detail. Now, what is forward biasing? In simple terms, when DC voltage or supply is provided to the PN junction in such a way that the potential barrier is reduced. The potential barrier, let me show you this potential barrier which we discussed in our earlier video. This potential barrier gets reduced by the application of electric voltage or supply in the opposite direction. It is called as forward biasing. Now, this is the schematic diagram of the mechanism of forward biasing. So how to apply the supply voltage such that the barrier potential decreases? In forward biasing, the p-type end is connected to the positive terminal of the supply, while the n-type end is connected to the negative region. So here you would have noticed that the barrier potential is from this direction, positive to negative, the barrier potential. But here we are applying the potential from here positive, this one is the positive terminal, and this one, the n-type end, is connected to the negative terminal. So this electric field generated by the supply voltage is in the opposite direction to the barrier potential. So the width of the depletion region, WD here, this WD is the depletion region width, while this VB is for built-in potential. So this barrier potential and the depletion region width both decrease because of the application of supply voltage in the opposite direction. And at some forward voltage, the barrier potential is completely eliminated. We will discuss about those terms in my later videos. Let's just stick to the modes of biasing. Now, here we are going to discuss about some key points related to forward biasing. So, obviously the potential barrier is reduced due to the application of supply voltage in the opposite direction, and at some forward voltage the potential barrier is eliminated altogether. Now, because of the reduction in the barrier potential, the junction pathway, the PN junction pathway, offers very low resistance to current flow, low resistance to current flow in the forward bias mode, and this resistance is called as forward resistance, RF. Now, the current flow in the circuit is maximum or higher in case of forward biasing, as the potential barrier is reduced and the junction offers low resistance. Next, we are going to discuss about reverse biasing. The definition of reverse biasing is that when supply voltage is given to a PN junction device such that the potential barrier, the barrier potential is increased, then it is called as reverse biasing. So, how to increase the potential barrier, or the potential barrier is increased when the p-type end or the p-type material is connected to the negative terminal of the supply, while the n-type end is connected to the positive terminal, completely opposite to that of forward biasing. In that condition, the PN junction is said to be reverse biased. So, it is just the opposite of forward biasing. Let me show you it in the schematic diagram. Here it is, the reverse biasing schematic diagram. Here, the p-type region is connected to the negative terminal of the supply voltage, while the n-type region is connected to the positive terminal. So, as you would notice, this barrier potential gets increased. The depletion region width too increases as the negative terminal attracts the holes towards it and the positive terminal attracts the electrons towards it, thereby depleting more and more region of the PN junction of any type of charge carriers. So, no holes are present in this region, no electrons are present in this region. All total, no charge carriers are present in this region. So, again, let's discuss some key points related to reverse biasing. As we discussed, the barrier potential increases because of reverse biasing. The junction resistance increases, and that resistance is called as reverse resistance. So, it is the opposite phenomenon to that of forward biasing. In forward bias mode, the junction resistance decreases, while in this case the junction resistance increases, and that resistance is called as reverse resistance, R subscript R. Now, the current flow in this case is negligible, almost zero, because of the high resistance or the high junction resistance. So, there is negligible current flow no current flow in case of reverse bias mode. Although there is some amount of current flow due to the minority charge carriers, such as the electrons minority charge carrier in the p-type region, while some amount of holes which act as minority charge carriers in the n-type region. That current is called as reverse saturation current. So we will discuss about the current flow and the volt ampere or the current voltage characteristics of PN junction devices in my later videos. So here I have discussed with you the various methods of biasing. First of all, the definition of biasing, then the various methods of biasing, and the various phenomena and properties which are associated with each biasing concept. So thank you very much.